Alright, I think we're recording. So, a couple of videos to respond to, Hythloday and Robert Ritchie. So, he has this spinning disc experiment that's intended to, in some ways, illustrate or demonstrate or experiment with the phenomenon of levitation, like lev trains and whatnot, the whole idea of Lenz's law. The idea that you can create a reflexive magnetic field in a non-magnetic substance by irritating it with a moving magnet. Alright, so he spins this up really fast. So it's going fast and it levitates fine. And then he speeds it up faster, and instead of going up higher, it goes down. Not much, but does go down instead of up. So there's two things that I think are the issue here. So I guess I'll do the obvious one, well, the simpler one first. So it's a spinning disc. What it's doing is it's creating low air pressure. So the spinning disc is sticking to the air. The air in between the gap there is being pushed out by centrifugal force. But obviously it's just being spit out because there's no obligation for any of the air to stay in the orbit, so to speak. So the air actually flies out of the orbit of the spin. So you're reducing the air pressure, the air density underneath the disk. And by reducing the air density, you reduce the capacity for it to have air pressure. So the pressure is lowered, and that's why the disk is compressing, is because the differential in the air pressure is creating a force, in the sense that it's the absence of force, right? There's a low pressure, an absence of force, more force from gravity. The two things are being smushed together. So that's why it's going down. The reason why it's not going up is because the force is limiting. All right, like a resistor or something else, there's a point where the thermal problem, causes a out of control cycle, and it'll stop all function. And so it's a histogram. So essentially your line is not a straight line. So you gain a little bit, in the middle you gain a lot, and at the end you gain a little. So a little tiny bit of motion isn't great, but a certain amount of motion, you start really maximizing your effect. And then once you get to a certain amount of motion, you can't get any more effect out of it. You're done. You've already gotten all the magnetism you can create out of it. So at a certain spin rate, you've essentially put the magnet on all the locations because of the speed of the spin. The effect takes a little bit of time. You can sort of understand that. I mean, nothing's happening instantaneously, so everything has a little bit of a time delay. So the faster you're going, there's a point where you're going faster than the material can react, and you're not going to get anything out of it. So you've reached its maximum potential to stimulate it with magnetism, and you just can't get any more levitation out of it because you can't create any more magnetized elements. It's like a magnet. You can only get so much magnetism out of a magnet, right? We can't make a nuclear magnet that's super magnetic. You can only get so much out of a certain density, and that's it. It's all the magnetism you can get. So in a sense, at a certain spin rate, you've hit the peak, the histogram, and you're just not going to get any more out of it. You could put in 10 million watts and you get 2 watts more of magnetic energy, kind of thing. It's it doesn't stop entirely, but it's might as well be a dead end. It's so close to a dead end. So I think that's all that's really happening here. So it's the low pressure problem, and you shouldn't have an expectation that there's a linear curve for how this magnetic effect happens. It's really not linear. It's a funny line. It starts off a little slow, and it finishes at a dead end, essentially. There's a peak, can't go above the peak. So those would be my explanations to Rob. So off to Hythloday. So I'm not being obnoxious. He asked, I mean, it's not, I would have responded anyway, but he did actually leave a comment saying, look at this video and see if you have anything to say. So, I'm not being, I don't mean to be patronizing in some way or anything like that. I'm just saying it was, like, the first thing I observed was, obviously the air pressure thing is a real effect. So you always got to realize we're in an atmosphere and the things you're doing aren't frictionless, and there's going to be consequences to being in, essentially we're in a kind of water. If you were doing the experiment in water, it would probably occur to you that, oh yeah, I'm pushing the water out. The non-compressible water. Anyway, so off to Hythloday. So I won't play the very beginning of this because he's just doing his usual blah 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 blah, and somewhere in here he gets to some sort of real point. I don't mean to degrade the video, but there is, conceptually, I can only do so much. I can give you metaphors, I can try to explain things. You can't take the analogies as explicitly true for all, levels of specificity. I can only use the language we have. We have words like energy and force. I've tried to make it as clear as possible. I've pointed out the force is the stuff moving the speed of light. Okay? The matter's the stuff not moving the speed of light. So if you can identify something and it's not going the speed of light, it's not a force. It has force in it, but it's not a force in itself. It's something else. It's holding force. It's not force. It's a boat, and it has passengers in it that are paddling. The boat has no paddles. Let's just say there's no oars in the boat until something gets in the boat and it's oaring the boat. And the oarers are what we're replacing. When two boats interact, they switch oarers. That's what the kinetic balls are doing. They're not switching matter, they're not switching, they're just exchanging oarers. They're little bits that are moving the speed of light. The oars are always moving the speed of light. They only oar at one speed, you could say, and they only oar in one direction. Alright, so I don't know how to make it any simpler. I don't know how to use some other verbiage. I mean, his critiques are, he does, I'm using the same words they're using. Well, no, I'm using the same words the human race uses to describe effects. Now, I could say that, their definition of energy is a little sloppy because they don't recognize the difference between potential we see, potential differences, and potential differences we don't see, right? Because we don't call the ones we don't see energy. I could argue the ground state of the Earth could be elevated by 1,000 degrees, 1,000 volts, and we'd never notice it, so to speak, because everything else would be relative. And that'd be a lot of energy potential, but we wouldn't know it was there. And it's only the stuff we can recognize, the potential differences we see, that we call energy. But clearly the energy could go a lot deeper than that. So I use the word force instead, just to say there is this stuff moving the speed of light, and it, wherever it is, if it's free somewhere, it has the potential to be not free, trapped, and therefore causing something to move. Its potential is in its existence. And there's a certain amount of it, and there's a certain amount of this stuff it can stick to, and that relationship or that tug of war is what the universe is involved in right now. The atoms are the stuff compressed in the sense that it's stuck to these bits. It's not going anywhere at light speed anymore. If it's moving at all, it's moving much, much slower because it's fighting against itself. There's force bit going this way and force bit going this way, trapped on the same atom, and obviously those two forces as movement cancel out. The thing will paddle this way and it'll paddle this way, so the boat won't go anywhere. Especially if people are doing that in the same side of the boat. You can see if one person's paddling this way on the same side of the boat and another person's paddling the other way on the same side of the boat won't go anywhere. Won't even spin. Alright, so I will attempt to, I've done it so many times, And it just says, you know, well, I guess you just can't get it. I don't know. I don't know how much, if I have any more help for you. I'll play some of his video first. So, and I've said so many times that the material bits never hit each other. They just don't, in theory, ever hit each other. They're always reflecting, as I just pointed one of my bullet points, okay, it's, you know, in the video, they're always reflecting the universe that they're getting hit by. And the only complication is that they can sometimes absorb stuff, and then later, some 10 years later, they can give back that stuff. So the reflection will have an augmentation to it, a little difference to it, because they've changed it by letting loose an ore they've had for 10 years. And now they're going to go in a new direction because they got rid of that guy. But everything's excreting these little bits of matter, the electrons and protons, are radiating what's hitting them. So what's hitting them is coming back out. They're at an equilibrium, so to speak, a temperature equilibrium. So they have stuff in them, but essentially they're just radiating to the universe whatever the universe does to them. And again, the difference is when two of them come into proximity, it's going to change how they radiate. And that's all there is. So it's just a reflection of your history. Your reflection is a reflection of your history, just as human beings are. We're a reflection of our history. Our history is built into our structure. And as the universe hits us, it will be blended with our history and we will excrete a reaction. But we can't react outside the boundaries of either our history or the environment that's hitting us. We can't make up some third force or some third influence. Those are the only two influences. What we've captured as an identity and what is coming at us. My reaction right now, my action in the universe, is being dictated by Hythloday excreting a force at me. My brain is reacting to that force and saying, God damn you imbecile. Okay, that's what it first says. And then it says, okay, I'll try to explain it again. And again, and again, and again. Because that's my history. And then I'm going to excrete this response. And that's all the little bits are doing with energy. So here I've given you a very complex, high universe analogy for the very simplest thing in the universe. Okay, so clearly this complex 100 billion neuron brain reacting is so distant from this simple mechanical energy force. But here I'm showing you it has a huge analogy. The comparison is there for the taking because it's very much the same thing. It's conservation of interaction, of action, of influence. It's all has to be conserved. So you know there's little granules of stuff, and it's just the formation of those granules that I'm reacting to. There's no magic bits. Clearly. Alright, let's play some of it and then I'll make the effort.
Use of terms, you see. I find DraftScience will use, because of the conversational manner of the proposals, that you will call the elemental bits, you will find in the dialogue, sometimes called momentum, sometimes called energy, sometimes called...
Yes, you have to think about it. Force, the one I use all the time, which I try to use some generic term that can't be fucked up. Force really can't be fucked up, right? I mean, it doesn't have like potential energy versus actual energy. It doesn't have any of that kind of crap. Force just says, yes, I understand the idea that something, conveys an influence. It's going to change the world because it's a thing, not a non-thing. So it's a word I thought you couldn't mess up. But again, I've explicitly defined what the nature of it is. The nature of it is a corpuscle of this crap moving the speed of light. And I've made it clear that the way you get a change in the universe is by just merely having two forms of the force and then having two matter bits that act inversely to those two forms. And now you can have huge change in the universe. If all I had is the force, I've said it explicitly. If all there was a force kinetically reacting, you couldn't see the universe do anything, because every action would be moot, because it would look like a non-action. If everything just reflected like kinetic balls, it would look like everything just missed. There would be no difference between a universe where they hit each other and a universe where they missed each other. The two universes would look identical. So you couldn't have any change. But if you can take two things of a different color and recognize that now their reflection means something, because this different thing can go in a new direction and this different thing can go in a new direction, then you have change. Then missing each other doesn't look the same as hitting each other. Alright. I've said this stuff, so this stuff you should already be on this level of granularity. You shouldn't be still stuck with a what is a bit and what is a piece of matter. We've already gone through the levels. The force bits are all the same, and all you can do is give them a frequency or segregate them for color. That's it. They have the speed of light, and all you're doing really is if one of those little things going the speed of light hits me, as I pointed out, that speed has to be divided into my entire mass. This has a mass of 1. I have a mass of 10 zillion. You divide by 10 zillion this thing's speed, and you come up with my end result speed because of this influence. Because this thing jumped into my boat, when it jumps in, it will give me a kind of momentum. Now the boat analogy isn't perfect because obviously you're jumping into a material object and you're causing a force interaction that's much deeper than the purpose of this analogy. But I'm just saying the little bits work not by the same principle as the boat, but by the same effect. So the little bit jumps in the boat, and the only thing that happened is the initial action is the only action, because everything that happens after that inside the boat can't possibly add any energy to the system. It can't add any force. It can't add anything. It's just caught in a circle, and it just circles, and it doesn't matter because everything cancels. All the motions cancel while it's sitting in the boat. But the first action into the boat never gets canceled. So we're conserving angular as well as any other kind of momentum. How else to say this? So anyway, I can't use any other words. If you can't get it, I say force bit, matter bit. I've said that 5 million times. You have to make a distinction. You can't just say particle, 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 particle. You can't just say atom is a bit, electron is a bit, force is a bit. No, you have to use the correct titles. Okay, force bit, then there's matter bits. And yes, you have to understand that matter is, an atom is a composite of the elemental bits. And I've made it clear what the elemental bits are, which are electrons and protons. And I've made it clear that electrons and protons excrete a ton of force at each other, and that they never hit each other. They react to each other's force radiation, their pressure. So, I mean, you really have to make some effort to follow along. You can't just take a CD and say, these are atoms, these are electrons, these are anything I care to say they are. They're not just particles. They're not just matter bits. You have to identify them.
Force, yeah, and it's contextual, because sometimes he can be using these terms in the context of orthodox science, and he means what they mean in orthodox science, but in
bullshit. Every time I've used the word force, I've made it clear. I've made it clear the force moves the speed of light and it has mass. I've never made any comparison to any other bullshit. I've said if to have momentum, it has to have mass, and I don't even give a shit about this word mass. It just doesn't goddamn matter. But clearly, Okay, clearly, if you're going to use some mathematical equation that's m times v equals c or something, clearly, all right, if you don't give it mass, then you're saying it doesn't have any momentum. Clearly, it has momentum. So if you have a formula that says you can only have momentum if you have mass, well, then clearly it's got to have fucking mass. Duh. I'm not the one confused. They're the ones confused. Just take me for what I say, please. I can't... What? Do you want me to actually... Am I really forced to make up new vocabulary? You can't understand the concept of force bit moving the speed of light that moves in a straight fucking line? You can't? It's that fucking simple and you're going to give me fucking vocabulary crap? You don't understand the definition? Even though I say it almost every fucking video?
Aiming to provide palatable insights into and metaphoric analogies that you can follow and understand these propositions. These terms, I think, are used too interchangeably in his paradigm.
Bullshit. I'm just saying, I'm just going to say it overtly. This is a bullshit, whiny pile of crap nonsense. Again, I have defined the parameters, the properties of the force bits so explicitly over and over and over again. And I keep saying the matter bit has no identity. Without passengers, it has nothing. It has no meaning. It doesn't exist in the universe. So until it has some ability to exchange force, okay, to absorb it, to reflect it, it doesn't mean anything. To exchange the bits of force. Again, it's for the boat analogy. What's happening is the two boats have people in them, okay, that are paddling. The two boats hit each other. What happens when they hit each other is, hey, the guy here on the boat that was paddling that way pops into this boat. And the guy in this boat that was paddling that way pops into that boat. And then the two boats end up leaving because they exchanged their pressure. They exchanged force, pressure. The ping pong paddle analogy. 3 ping pong paddles. I move this paddle closer to this middle one, then that pressure is felt here because this moves. It puts more pressure on this one and it makes this one move this way. I mean, it's that simple. I've used the word pressure over and over and over again. All these are pressure exchanges. The force bits are the mechanism of pressure, and they're clearly exchanged when two matter bits come into proximity where they can feel the radiation coming off of each other.
Now then, what comes is the problem is what physically, mechanically happens when this body of averaging speed hits this.
All right, now I avoid using words like the body. So again, when you say this body, you're obviously drawing an atom, I think, right? So when he says this body and this body, so he's really saying atoms. And we're saying atoms are covered in electrons, okay? They're the things, you can't get to the protons. Protons are going to be irrelevant in this kind of conversation for the purpose. The only purpose they serve is to bind the electrons and to create the opposite force to the electron's repulsion. So the electrons are repelling. They hate each other. They want to be this far apart. Okay, this far apart. That's how they want to be, this far apart. But they want to get to the proton. So they accept being this far apart. But they're all under pressure. So there's a huge tension in everything. Everything is radiating force. So the electrons are radiating force at each other. The radiation from this thing is saying, get the hell away from me, you fucker. And the radiation going this way, okay, from the proton is that, yes, it's attractive, so it's that there's an absence of pressure, so the external pressure is pushing them towards the proton. All right, and that's the binding energy of the atom. And what's going to happen when two CDs come into each other, the CDs are never going to touch each other. The atoms don't even interact in any way whatsoever. The only thing that's going to interact are the electrons. And as these electrons in the atom, right, on each CD, those little dots have pressure between them. So let me draw it. Yeah, a little bit of a choke. Anyway. Alright. Paper. Alright, so this is what he's got drawn. Alright. So there's no line, okay? There's no this, there's no surfaces, there's none of this crap. So the atom is protons, and then we have bound electrons in some formation or other. And when two atoms, all right, come into contact with each other. So the first thing you understand, there's this pressure in towards the protons, and then there's this repulsive, okay, pressure between the electrons. So there's two arrows there. You can see they're bouncing back and forth. These are the paddles. The electrons are just paddles. They aren't ping pong balls. They're just paddles. And they're being hit by stuff. And however they're hit decides where the electron moves. So the electron only moves if more ping pong balls hit it in some direction. So the external world is hitting it with ping pong balls. All right, and then there's a regulation of them in here. The whole point is there's the proton, the nucleus of the atom has electrons and protons in it, and it has a formation that allows it to mitigate the black pressure, the pressure reflections that might irritate an electron. So the electrons are moved towards the proton. Well, I shouldn't have to explain that. So anyway, the whole thing is in a pressured vessel, and the pressure is mediated inside the atom through the positioning of the seats in the atom boat. So I don't want to even do, I don't want to blend these analogies. But you can analogize them. All levels are it's the same thing, because as I pointed out, even in philosophical terms, you can understand the conservation of interactions. All right. Anyway, so these are the things that are going to interact with each other. And if you just zoom in on this little segment, okay, let's zoom in on what that one electron is. That, as pointed out, that one electron is radiating force, radiating ping pong balls to the universe. The universe is hitting it, and it is throwing them back. And it's throwing more back in some directions. There's more than there are in other directions. But that's what it's doing. Okay, anything that comes into it black, it's reflecting back. And so what's going to happen when two atoms interact with each other? Okay, isn't that two atoms are going to interact with each other. No, what's going to happen is two electrons, the electron in this atom and the electron in this atom, are going to interact with each other. And these two atoms, okay, let's put a little density of, you know, the force. So this is sort of the force density of, this electron. And it's going to come interacting with another electron. Well, you can sort of get the idea, okay, because of the way the force is being mitigated here, or produced here, that there's some momentum in this direction, okay, because of these two strong forces. But this is, again, there's the attraction to the proton here. So this is under tension, this is under tension. So when these two things, their forces start hitting each other, and that's what's going to happen. This force has to go, let me do it in red just so you understand it. The force from this electron, the stuff it's throwing, the ping pong balls, have to actually get to this electron. The two forces won't, the ping pong balls can't hit each other. This ping pong ball off this one has to, you know, a ping pong ball comes in, bounces off, goes all the way over here, and once it hits, then it'll impose a force on that boat. Okay, that's a person jumping in the boat. See, that's how this is a little more complicated than the simplicity. I gave you a simple analogy that takes out all the noise, people. But you could think that they're, okay, take the boat example and recognize that there's real people and then there's zombies. Okay, and so I'm just going to highlight what the real people are doing. Okay, the people who are going to create change, the ones that are involved in doing something different. but there's a whole bunch of zombie people that are jumping, climbing in out of the water. They're coming in from the sky. There's a whole bunch of zombie people going in and out of the boats all the time. But we're going to say, for the sake of argument, that everything they do is balanced. So if there's a yin, there's a yang zombie. So those zombies don't matter. The only zombies that matter are the ones that create a difference in potential. The energy zombies. Okay, shit. But anyway, all right. So the only time it's going to react, the ping pong ball goes over, hits here. That's an imposition where we're going to have an exchange. So this thing hits. That means a guy paddling this way jumps out of the boat, and this guy, he jumped into the boat. So now we have in the boat a guy going this way, where before we had an imbalance going this way. So now we got rid of the imbalance this way, we have an imbalance going the opposite way. So this electron now, instead of moving towards the other thing, it's going to be moving away. So this is a very simplistic explanation, but I'm just saying you could sort of understand, as these two electrons get closer and closer to each other, this force will start to multiply. Okay, the pressure here, more and more ping pong balls bouncing back and forth, trying to make pressure exchanges. More and more people jumping on both of these boats, so to speak. Right? That's what it adds up to. Every time the ping pong ball hits, that's like somebody jumping into the boat. So obviously lots of people jumping into both of these boats saying, go this way. And it's obviously the only pressure is this pressure and this pressure. All these people jumping into the boat. And so something gives. And eventually what gives in the atoms is this pressure overwhelms these pressures, in the sense that these pressures are, this electron is finally pushed this way, which pushes these electrons this way, which pushes this electron that way. So the overall momentum of this whole atom is changed through the exchange of pressure, and it moves this way. And so the two things never hit each other. They just push into each other, the pressure increases, and they rebound away from each other. That's what the atoms do. Now obviously the way the electrons are specifically creating that effect is in a similar, but it's not exactly the same thing, because electrons never hit each other either. Because they can't. Because if they got that close to each other, there'd be so many interactions between them. The ping pong ball would be bouncing so fast. There'd be so much going out pressure. You can't create that pressure. That's like a nuclear bomb kind of thing. It's not the kind of pressure you can just make by, doing this with your finger. So I don't know if he needs a deeper explanation than this to just point out that I'm just trying to illustrate why. I'm trying to explain to you. We already know the conservation of energy is a real thing. It seems like a real phenomenon. I'm trying to explain to you how it works. That there's only a certain number of ping pong balls, there's a certain number of paddles, and all we're really talking about is, where are the ping pong balls? Are they free out here, or are they trapped between paddles? And you could sort of understand that I can configure an atom in a certain way where it has motion in a direction overall. There's a certain more rowers this way than rowers that way. And that the overall atom, because it's all pressurized, because each electron communicates with the other one. If this one moves this way a little, this one's going to know, hey, that's lower pressure. I can move into that. I have more pressure this way, so I'll move into that lower pressure. That they're always going to communicate each other's position to each other. Every little bit, every electron and proton in the atom is well aware of the position of every other bit. Okay, technically. They have complete, almost, knowledge of the pressure reality they are in. And any change in one bit is going to be felt by the other bits. So if one bit moves, every other bit knows the pressure equation has changed, and I'm going to be moved because I'm going to feel less pressure. Less people are going to be climbing into my boat from the front end than from the back end. I'm going to be making less exchanges on one end than I'm making on the other end. Therefore, I'm going to move in that direction because I'm going to have more rowers going this way than rowers going that way. I just don't know how, I don't know how many of my videos you want me to redo over and over again. I don't know what to say. I mean, you're not being very exact in what you're hanging on here in terms of understanding the concept. The matter bits, the electrons and the protons, never have their own momentum. They only have what they've acquired, what has stuck in their boat. And as they wander through the universe, all they're doing is exchanging rowers. So every time two boats hit each other, two electrons, they're just going to exchange their pressure. If this one is under more pressure, it's going to impose more force on the other one, so to speak. More of its ping pong balls are going to hit this thing than this thing's ping pong balls are going to hit this one. This one's going to feel more force. This one's going to react, which means it's going to push all of the other things in its atom, and they're all going to react. And so whatever the force imbalance was, whatever the difference in pressure, it's going to end up equalizing. This one will keep imposing more pressure as long as it has more pressure, and this one's going to accept it. And that's the nature of electricity moving through a wire. That's exactly how it works. The atoms are sitting here next to each other. You force more rowers into this atom. It does this. It says, I have more pressure. So the normal atom is like this. So they're normally just sitting there like this. You pressurize one of the atoms. Now it has more ping pong balls coming off of it. This one feels that and says, ooh, I have to do this. So as this one goes down, this one goes up, and they end up equalized again. But their new equal is higher than this. So they've shared the pressure, which means the one over here sees that and it also shares it. So the voltage moves down as long as there's a potential difference until it goes to zero. And that's how electricity is moving. As long as there's something pulling the rowers at the other end and saying, I accept all rowers, you know, you're connected to ground. Ground says, give me all the rowers you got. Then the rowers will just move from this atom to this atom to this atom to this atom to this atom. So as long as they have some place to go, then all the pressure will always try to equal out. And that's all that's happening between the atoms. And that's happening because it's happening to the electrons. The electrons are the medium, the boat. The force is the rowers. And all you're doing is migrating rowers through putting atoms in close enough proximity that they feel each other's pressure. As long as they can feel each other's pressure differences, then they can exchange rowers. The force will move down the wire. Or in the case of bigger things, the electrons will move, or the atoms will move. I think that should be it. I don't know. Like I said, this sometimes it just seems kind of hopeless conversing with Hythloday.
Say other body of some speed. Let's say we'll fix a frame of reference around this body and say it is stationary, and this is going to all intents and purposes, hit this body. And
okay, it says clearly state it's not going to hit it. It's going to just feel the ping pong balls. It's just going to feel its radiation. It's going to feel what's bouncing off of it. Just like I don't see you, I see the energy that bounces off of you. That's what affects me. And so we're really just saying the more pressure my atom has, the denser I am, and the more opaque I am. and then we're just, you know, and so we're going to affect each other based on how dense we are, how opaque we are, and how many photons we're going to be producing, in a sense.
Significant. What the analysis is, if we're to talk about the giving of fundamental bits, what did I say? Elemental bits from one body to the next body, which
so now he wants to get into some complexity about how how straight you can jump into a boat. You know, what angle is the boat at when you jump off the pier? If the boat is crooked, will the boat go straight or will the boat go crooked? I mean, this is getting into a detail. I can't give you those explanations. I can just tell you that we already know that that sort of doesn't happen, that angular problem isn't a problem, that stuff actually does get trapped. So I could argue, just going back to the drawing board, if you must have an image of the electron, if you must have that level of detail. Again, regular physics doesn't even tell you how the magnet works. Regular physics doesn't even tell you what force is making things move into each other. Regular physics doesn't give you any detail. And again, look how strangled he's going to force me to give you. So clearly I'm pointing out how these electrons and this force gets trapped between the electrons. Well, obviously if I make them circles, then stuff is going to bounce at all kinds of funny angles and it's going to escape pretty fairly easily. And we know that sort of doesn't happen. So in a sense, you could say that electrons may be, circles, it goes, maybe they're shaped something inverted, like they're actually shaped something like this. So then whenever they're in a relationship with other things, they have a primary, a place where the reflections are always captured because there's a parabola, and the parabola just tends to force everything to a focus, and the focus is their distance, and so they parabola to the distance of the force that's bouncing back and forth. So you could say that's their resonant frequency, and as their resonant frequency changes, the parabola changes. I mean, there could be all kinds of mechanisms that ensure that once force is trapped between two electrons, it stays trapped between the two electrons until it goes to the other side, okay? Until it, so let's say a whole bunch of force here, right? The idea would be is that force would be spread to another interaction with another electron, say down here, and so now that force would end up in this trap. So all you're doing is moving passengers from little bits, from force bits, from this path to this path to this path to this path. But there could be a myriad of mechanisms that ensure the consistency and that you don't have a total too much chaos. Like I say, even round will probably work. I'm just saying that, it just makes it easier to follow the bouncing ball if you have rules that confine the bouncing ball. But it probably doesn't matter.
Science seems to suggest. What is the difference and the contrast and the significance of points of contact? You see, the two disks...
So again, there is no points of contact. The force, as I've said all over and over again, force pushes matter, okay? Matter doesn't interact with matter. Force doesn't interact with force. There's only force interacts with matter, and matter interacts with force. So matter moving can cause an increase in the energy of a force, and a force hitting matter will cause the matter to move.
Or spheres, as these are just really meant to be representations of a spherical body. When two spheres hit, there is like very limited contact at a point.
So obviously, as I've pointed out, the two atoms never interact. Only the bits that make up the atom ever interact. And the bits never hit each other, the matter bits. Their force they're radiating reaches the other one and hits it. Just as, I mean, gravity you can't use it as an example because it doesn't have the reflective force. There's no reflecting energy. But you can understand it as magnets. If I put two magnets, the same pole, flat on a surface, they'll have that repulsion, and you'll understand that you can push one magnet with the other magnet. The two magnets will never hit each other. One just pushes the other with its force.
But if two cubes hit, there's a whole flat surface of contact. And it provides flexibilities and degrees of options and questions about whether transference of elemental bits is
I'm sure the shape of the atom makes some difference in how the interactions between the electrons. So if there's two electrons on one atom and only one electron on the other atom, then the force exchange is going to be more complicated because there's twice as much energy hitting one from the weaker atom than on the stronger atom. But again, then that just means this one will impose further into this one and there'll still be a balance. So I'm sure the geometry matters. That's why different substances look different. That's why the molecules, the atoms, the 100 elements have different properties. Is for that very reason, because of the way the atoms are capable of exchanging pressure. So why do I need to answer this grain of why do you need this grain of detail? I just don't understand. I mean, I've made it as clear as possible. You can say, well, I don't see how it's possible that, ping pong paddles could have ping pong balls between them. Well, okay, you can't understand how that can happen. I'm just saying that's the way I see it. That's the way the entire universe seems to work in terms of that's the basic function. There's stuff moving, the speed of light, the ping pong balls, and the paddles only move if the balls tell them to.
What DraftScience seems to be suggesting is either through a point or in the context of a flat surface, is it through the entire surface? And
see, now he's trying to put a surface on an atom, right? Again, so it's just like so everything's tables, right? They can't, they tell me the table right in front of me is mostly empty space, and they're all comfortable with that explanation. And then as soon as they start drawing an atom, all of a sudden they're turning it into a table. I just don't get it. Where's all this empty space if it's supposed to exist? Because you don't seem to be able to recognize it really. You turn everything into some fucking table.
The proposal is this, if I'm understanding it right. This seems to entertain the notion.
Clearly, you're not understanding me right, because your metaphor just isn't even using the same idea. Again, the two atoms would be radiating force from their electrons, primarily on the outside. And so you're not even acknowledging the ping pong balls here at all. You're just pretending they don't exist. And here you are a second level up, so there's ping pong balls between all those dots. And the atom themselves has a character. Certain places a certain kind of ball is leaving, a red one, and in other places a black one is leaving.
Of non-average velocities. In that in some way, the mass of this is transferred to the mass of this.
Okay, there's no mass transfer unless you're going to say that the only thing that has mass is the force. And I would be perfectly comfortable with that, frankly, in some respects. The force is the only thing that has any mass, and the things we're thinking have mass. The protons, the electrons, the whatever, all the little gluon and pooons. No, they don't have any mass. They don't have nothing until they collect the mass. They have to collect it. And we can sort of see that. This has mass because it has momentum. All right? It's being pushed onto the scale when I measure its weight. So weight is clearly a measure of momentum. But I could argue that so is mass. That if I make this thing go fast enough in one direction, it won't have mass in any of these directions. I won't be able to detect it. It'll be just about invisible. Can't mean anything. Can't make any exchanges because there's no rowers in the right direction. I can't exchange one for this way. I can't exchange an up for a down. I can't make any of the. There's no currency. Okay, it's all in francs, and all I got is American quarters. There's no way to, and it's certainly invisible from this end. I mean, this end, it certainly has no mass. So when a bullet's flying through the air this way, it certainly has a hell of a lot more mass at this end than it has going this way. It's, if I'm standing here saying, what's your mass? It's going to look almost like it has negative mass.
And so... And if the defining quality is that this is moving because it has, let's say, three particular bits, which
so you have to understand that's a whole herd of boats. Okay, those are a whole bunch of boats. So each electron's a boat, each proton. So there's a bunch of boats, And then the boats all have ropes tying them together, theoretically. You know, I'm just using ropes in the sense of tension. They also have things jumping in and out of them. And the whole group of boats, it also is in a sea of the, like I said, the zombies who are climbing in and climbing out all the time of the boats. So the motion is dictated by all of these levels of groupness. But I've made it clear the primary function is force bits moving the speed of light, moving a dead straight line that just have their I'm paddling, and they capture the paddler in a direction. They capture its momentum. I only paddle this direction. I get in somebody's boat, that's what I'm doing. I'm paddling in that direction. Because that was my initial, that's how I jumped into the boat. That's what I am. And clearly, I explicitly say the only real players in this whole drama, the only universe is this tiny universe. The rest of it is just a manifestation of what they're doing. So the only boats we have to pay attention, fuck the fucking school of boats, fuck the bigger picture boats. Who cares if you understand the mechanism between boat and boat? And I've tried to do that. I've tried to point out to you. It just, the rest of it doesn't matter. All there is an electron that has ping pong balls hitting it more this way than this way because it's tied to an atom. And this one's tied to an atom. Those two atoms, those two boats are under a pressure, tension. And when they move towards each other, they're going to share tension. And that tension is going to blend into all these other tensions, and they're going to exchange their condition. Whatever disease this thing has, whatever virus or sickness this atom has, it's going to give it to this one.
In this one, okay, in what sense have we understood that all these bits were averaging this velocity this way? And if it seems to be that proposition seems to break the principle that for a body to be a body, they all must average the velocity. Yeah.
Yes, and all that averaging happens on one level. It's always on the elemental level. It's always happening on the smallest universe level. So you're just losing the picture because you're making the damn thing, you're making the bits too big. And you're saying, why aren't these big bits behave exactly like the little bits? Why aren't solar systems atoms? Because they're not. Okay? They're similar, but they're not the same thing. So argue the level of the universe. I'm giving you the point. This is the point. This is the level of the universe where the action happens. This is where the boats are. This is where the water is. All right? Don't do this. I vaguely see a school of boats here, and I vaguely see a school of boats here. How are they interacting? That's, I can explain it to you, but again, I'm going to have to explain it to you by explaining what 1 million individual boats are doing and exchanging their energy then. I can give you the mechanism. When you start to make the mechanism bigger and bigger, now you go from 1 million elements to 10 zillion to a quadzillion to zobzillion. I mean, it's like you're sitting there showing me the universe and saying, well, how is the Earth interacting with the sun? Well, yeah, there's about a zillion, gazillion little interactions, aren't there?
If by just transferring a portion over, this whole body somehow stops going, and in a Newton's cradle would be the ideal example to explain this. The Newton's cradle, this stops, yeah, and it transfers its whole body.
Yes, and you can understand it that it's always hard materials that do that, not soft materials. So clearly the atoms are in rigid conditions. The atoms don't have a bunch of flexibility in their movement, so they clearly easily transmit pressure to each other because there's so much tension. The springs inside of a metal are really tight springs, so any kind of movement at all goes right through all the other springs. The passengers jump boats so easy in a metal. The boats are so close together that rowers can jump the boats so quickly, so efficiently.
to the secondary ball sphere through a point, mind. And so we need a mechanical analysis of how its average velocity of, say, 0.5 meter per second suddenly becomes 0. And this becomes 0.5 meter per second.
And it happens again, so you want the explanation. Again, I already gave you the atomic one is going to be, it's going to happen a little bit at a time. Two atoms have different pressure. They get close enough to each other, then any increase in pressure here will average out between the two of them. The next ones will also average, and the average, and the average, and it'll decline, right? So it won't be like what you want, this black and white exchange all at once. That's not the way it happens. It happens by averaging. And it takes time for the average to take place. So even though the kinetic balls look like, oh, it happened instantaneously, well, it really didn't, okay? So if you could look on the real small scale of the universe, when the two balls hit each other, there's no instantaneous reaction. It takes a little while for all the pressure to be migrated through the objects and for the exchange to take place. It takes a little time for all the little rowers in one ball to move into the other ball.
All of the bits now, and remember, recall, these two balls would weigh the same, but now at this point of collision, this moving body would also have to be averaging, as we understand the body, the entirety of the 0.5 meter per second. So how can a small portion give this whole portion the entire velocity? That's not clear in the explanation of.
I think it's perfectly clear. They're all under tension, and the little ping pong balls that are mitigating the pressure, they're the ones exchanging the pressure, essentially, based on being compressed and relaxed. They're moving the speed of light. Clearly, the pressure moves very fast, okay? And the only part that slows it down is the fact that the ping pong paddles do have to move a little bit to make changes in pressure. So there's a little bit of a slowdown because of the slowness of the ping pong ball, the paddles, the boats. But other than that, the thing moves very fast. When a person jumps from one boat to the other boat, they jump at the speed of light. They don't jump like they don't crawl into the other boat.
As you most recently made, I got lost with metaphors about people in and out of boats and all rowing, and a certain amount rowing in a direction and a certain not other. The way I understand motion is that to have a particle model without abstract forces and energies and such, these are all abstract numbers in orthodox science.
Yes, they're full of shit, right? So their abstractions are irrelevant to my point. I'm telling you, I'm agreeing they have noticed that there's a conservation of this thing called energy. So at least they're conceding the obvious facts. All right? And they're the ones, though, that borrow energy from vacuums and do all kinds of wacky shit that I would say is totally invalid. You can't do that. That's cheating the system altogether. You allow them to do all that crap. I'm not doing any of that shit. I'm telling you, this is why there's conservation of momentum. This is the machinery. Yeah, everything has to be accounted for. Every little ping pong ball is a real ping pong ball. It has a forever life in the system. No ping pong ball is ever destroyed. Okay, so it always has to be accounted for. And all we're talking about is the fact that it creates more and less pressure when there's paddles in proximity. Ping pong balls become very energetic when paddles are in proximity. And those are the simple rules. And you're trying to make this complicated. You are trying to make it complicated.
Isn't the high school idea of the amount of stuff in something? Mass becomes an abstract number. You know, there are in orthodox science.
Again, just forget about it, okay? Only use it as a reference point to what the capacity of a boat is. Mass tells you capacity. If you want to use it for some idiotic purpose, it tells you how much stuff, how many ping pong balls can be held in the boat, how many rowers can be in a boat, how many rowers in the total piece of something. So if I have a lead ball, it has lots of rowers, lots of seats in the boats.
Mental bits.
It doesn't mean they're all rowing in one direction. It doesn't mean anything. It could still be sitting there doing absolutely nothing. But obviously, if I give it a bias, if I push more exchanges from gravity in, it has lots of capacity to exchange rowers. So there are lots of the rowers will get moved and changed, and now it has a whole bunch of rowers moving in one direction. That's why it has more mass, momentum, weight.
Photons, which have no mass, and suggested the graviton also has no mass.
I've told you right to your face, they are full of shit. I don't have to accept an idiotic notion they made up. It doesn't even make any sense. So instead of criticizing what they're saying, instead of pointing out how they're the ones with the preposterous fucking contradiction, right? They say that fucking photons are moved by gravity, right? We know that gravity only works on things that have mass. They say, Einstein explicitly rigs the fucking math and says photons are affected twice as much by gravity. Twice as much! And then you're going to tell me they say it doesn't have any fucking mass. They say it's moved twice as much by gravity, and then you tell me it doesn't have any mass. That's what they say. Why are you arguing that crap to me? Why aren't you pointing that at them and saying, that's an overt, impossible contradiction? That is baby talk. That's fucking nonsense. How the fuck can a photon be twice as affected by something that only affects things that have mass? You explain that to me, you dumb fuck. Why are you giving me a vocabulary lesson when they're the ones with the ludicrous fucking definitions? I mean, this is just such bullshit. Your double standards are bullshit. I have to explain why they can't figure out the obvious? I'm not the one saying photons don't have any fucking goddamn momentum, jackass. They are!
But these are existent proposed particles. So things that exist don't necessarily have mass because it's an abstract number in orthodox science. But when DraftScience says a mass, in his talking about contextual his theory, he means the elemental bit. Same again when he says force, he means an elemental bit. And you can't, it's difficult to follow this explanation.
Yeah, no, it's not difficult to fucking follow. Alright, I have done this over and over and over again. Ping pong paddle, ping pong balls. You can't figure that out? Fuck you. I mean, this is just such bullshit to make some fucking ludicrous comparison. Again, like I have broken vocabulary when I have been explicit over and over. Force bits have the only goddamn real motion. The matter bits only move because they have fucking rowers in their fucking boat.
Without using the same elemental bit descriptor throughout the discussion, I find. And I'd appreciate it if other people have the problems with this crossover of dialogue talk.
Yes, right. I would appreciate if the trolls sit there and agree with me that somehow I've made the fucking vocabulary mistakes when they have obviously broken what any fucking word in our vocabulary means. They say something's a goddamn particle, yet it's a fucking goddamn wave. Does that make any fucking goddamn sense? No. It's in two places at once. It's in any place in the universe at once. They're the ones with the fucking ludicrous vocabulary. And here you are nitpicking me, you motherfucking cunt.
What is orthodox science and what is DraftScience's proposition of a particular theory of a mechanical view of matter? Do other people find it similar?
Oh yes, do I find it too challenging? It's a ping pong paddle metaphor just too fucking challenging. I can't follow all the bouncing balls. I mean, ping pong paddle and ball bouncing. I can't follow that. It's way too complicated. There's no twice the speed of light in it. There's no it's both. It has mass, but it has no mass. Yes, it's affected by gravity, but it has no mass. Blah, 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 blah. No. I mean, you're just such a fucking duplicitous hypocrite. All right, so now he goes on to his little legal shit. I'll give you advice again.
Plus from the next court case.
Yes, his next court case. Look, go ahead. Waste your time. I'm just saying, I have so been there and done this. All right? They will not let you win. They won't. They'll give you a shred of victory here or a shred there to pretend there's some honesty in the system. The system has no honesty. They will never be accountable. So good luck, but you're never going to get your resolution. You're just going to keep doing their circular bullshit and wasting your time and money. We have no civilization, Hythloday. It's a lie, okay? Because the people running it aren't civilized. They're cheaters. They won't be accountable. They're not stand-up knights, you know, in shiny armor. All right? They're disgusting, manipulative thieves. Fuck. So, you know, I sort of asked myself, don't let him bug you. But I mean, his hypocrisy is so obvious, and I've complained about it so many times. I mean, this double standard. I have given you a colossal amount of detail about how things work. And here he is arguing over minutia. What's the shape of an electron? They don't even explain it, any of it coherently. None of it. They have no fucking drawing of any of it. And here you are nitpicking. Alrighty then. So I guess that's the end of the video. Sorry about the yelling. But it is just, you know, at some point I'm saying, okay, there's some sort of hope of a rational conversation. But clearly these double standards are going to make a rational conversation impossible. They'll always nitpick. They'll always naysay. They're just going to keep me going around and around. Oh, I can't get the jump. You jump on a boat and it makes the boat move. Oh, I don't know. I can't get that. I mean, it's just fucking bullshit. You know, obvious bullshit. I mean, I put it in dead written sentences and they still don't pay any attention.